This section, we're gonna study improper integrals. So far, we study a lot of integral techniques, but this one is a little different from previous integration. So we're gonna use L'Hopital rule to evaluate improper integrals. Guys, this one is a little different from previous integral forms. So really pay attention this session. What is improper integral? First part of improper integral is gonna be, guys, here is boundary is infinity. So here is the first thing is infinity integral limit. So first you notice here, infinity is here. Usually boundary is on the bounded, low bound, upper bound, it's number. This time is infinity. This case, how can define this one, guys? Definition of improper integral is an infinity fx dx. This integration we're gonna do an t approach to infinity. That's the definition. So an infinity boundary. How can define this integral? Limit concept right here. And t value, t going to infinity. So this limit exists, this integration, improper integral exists. Another part is gonna be, you see, negative infinity is low bound. So that case, negative infinity can be, so you're gonna see right here, t to the b, t gonna going to the negative infinity. That's how to define this improper integral. So check it out, the boundary first. One of them is infinity or negative infinity. You're gonna write down this definition, find the first integration, take a limit. That's how to evaluate the improper integral. So improper integral, each of them, this one is convergent, meaning is this each limit converges. Okay? This integral is divergent, meaning is each limit is divergent. Next couple of slides, I'm gonna give specific example how to evaluate the improper integral. Let's do the first part. Here is improper integral with converse. So first one is look at this one. I sketch it 0 and infinity. Guys, look at this one, 0 and infinity. Definitely you see. Here is boundary is infinity right there. So you're gonna using definition of improper integral. That's you're gonna find it. So let's try this one. 0 and 0 and infinity e to the negative x dx. Definition is limit t approach to infinity, 0 and t e to the negative x dx. That's you're gonna find it. First you have find this integration, take a limit. So using the substitution method, you're gonna find this integration. This one is negative e to the negative x, 0 and t. So this is gonna be limit t approach to infinity. Limit t approach to infinity. When you plug in the t value, each negative t, negative e to the negative 0, right? So this one is 1. So this limit t approach to infinity, negative e to the negative t, negative, positive 1. Where this goes, we practice a lot. Previous slides, guys, previous session, t approach to infinity. This gonna be, look at this one, e to the negative t, gonna be t going to infinity, that's going to 0. So this one is 0 plus 1, the limit gonna be 1. That's how to calculate the improper integral, first one. This limit exists, this integration, improper integration is answer gonna be, this gonna be 1. Let's do the B part. So I sketched the graph right there, guys. So y equal 1 over x squared plus 1. This is, check it out, this limit. So this is infinity. This is going to infinity, right? So here is boundary is infinity. So what do you have to do using definition of improper integral? So here is 0 and infinity, 1x squared plus 1 dx. So this one is the limit t approach to infinity, 0 and t, 1x squared plus 1 dx. So you're going to calculate this integration. This is a limit t approach to infinity. Antiderivative 1 over x squared plus 1 is arctangent x. 0 t approach to infinity, arctangent t minus arctangent 0. Anyone remember arctangent t? That's gonna be, guys, t approach to infinity. This is pi over 2. Other way you're gonna see it, limit arctangent t approach to infinity, arctangent t, meaning is arctangent infinity value gonna be. So if you remember this one from the trigonometry, tangent pi over 2 going to infinity. So that's why arctangent infinity gonna be pi over 2. Minus arctangent 0 is 0. Why? Tangent 0 is 0. So arctangent 0 is 0. So final answer gonna be pi over 2. This one is converse. This improper integral, you're gonna say this is pi over 2. This time we're gonna do improper integral by using the L'Hopital rules. So what we're gonna do this one is, guys, definition first. Integral negative infinity to the 0, x e to the x dx. So we're gonna have this one. Definition of improper integral is infinity t approach negative infinity integral t to the 0 x e to the x dx. First, you're going to find this antiderivative of x e to the x. You're going to using integration by part. So, okay, first you're going to do integral x e to the x dx. Integration by part gonna be quick review u equal x, dv equal ex dx, du gonna be dx, v gonna be e to the x. So this integral gonna be x uv, x e to the x, v du minus integral e x dx. So antiderivative e to the x gonna be x e to the x minus e to the x plus c. So plugging back to this one, limit t approach to negative infinity. This one is x e to the x minus e to the x. You don't need to see because this is definite integral t to 0. So plug in the 0 first, the limit t approach negative infinity. Plug in the 0 first, 0 times e to the 0, that's gonna be 0, minus e to the 0, minus parentheses t e to the t minus e to the t. Now, e to the 0 is gonna be 1. This is 1, so you have this form. Limit t approach negative infinity, negative 1, distribute to negative, negative t e to the t plus e to the t. So t approach negative infinity, e to the t. Guys, remember this graph? X goes to this direction. That's going to 0. This part going to 0, guys, okay? But this one is a trouble. t equal negative infinity, e to the t going to 0. So this one is 0 times infinity form. So we have find the limit. So I'm going to separate t approach negative infinity, negative t e to the t. The other one is this going to 0. So negative 1. So you're going to find this limit. So you have to make 0 over 0, infinity over infinity. Which one you're going to send the denominator is up to you. So I'm going to put this one going to 0, this one going to infinity. So one of them going to denominate. So I'm going to put this one is a denominate. E to the negative t plus 1. Guys, make sense, this one? So I'm going to go into the next page. Let's find this limit, guys, okay? So now, only you have to do it. You have to find this limit, right? This limit. So limit t approach negative infinity. This one is negative t. I put the negative outside. T e to the t minus 1. So how can find this limit? T approach negative infinity. This going to negative infinity. This going to 0. So this is 0 times infinity. So I'm going to calculate this one only. One of them going to denominate to make 0 over 0, guys. 0 over 0 or infinity over infinity. It's up to you. So I'm going to put this going to infinity. This another one should be denominate. I'm going to write down this one, t approach negative infinity, t over e to the negative t. This is exactly same. So 1 over e to the negative t, meaning is e to the t. So now this going to infinity, negative infinity is going to infinity. So you're going to using L'Hopital rule. Antiderivative t is 1, antiderivative e to the negative t, e to the negative t, channel negative 1. So this, let's calculate this one. Simplification is limit t approach negative infinity. Negative is put here. 1 over e to the negative infinity. So t approach negative infinity. Guys, this one going to where? This one going to infinity. Denominator going to infinity. Whole thing going to 0, guys. So this one, now we calculate this part. This one going to 0. This one going to 0. So answer gonna be 0 minus 1. That's gonna be negative infinity. So make sure you guys understand this improper integral. Next improper integral is limit gonna be both sides, not the one side. Look at this one, guys. Look at this one. Here is negative infinity. Here is positive infinity. So that case, what you have to do, guys? What you have to use split two part. First part is negative infinity to the a. Second part is a to infinity. Usually, a value gonna be 0. That's how to find this improper integral from negative infinity and positive infinity. So another very important thing is this one is convergent, meaning is this one is converse. This one is converse. Both are converse, this limit converse. One of them is divergent, then this limit, this improper integral is divergent. Guys, make sure you understand that one. Let's do this improper integral with low infinity upper bound, infinity low bound, okay? So what do your definitions say? This one is gonna be separate. Usually a value gonna be 0. Negative infinity and 0. 1x squared plus 1 dx plus 0 and infinity 1x squared plus 1 dx. So that's you're gonna find each improper integral. You're gonna put together. Let's just start with positive one. Integral 0 and infinity 1x squared plus 1 dx. Limit t approach to infinity 0 and t 1x squared plus 1 dx. This one is limit t approach infinity. This one is arctangent. We did this previous example 0 and t. This one is limit t approach infinity. Arctangent t minus arctangent 0. So this first part going to pi over 2. Second part going to 0. That's gonna be pi over 2. So this one is pi over 2. Now, first part, integral negative infinity and 0, 1 over x squared plus 1 dx, limit, definition is t approach negative infinity, t and 0, 1 x squared plus 1 dx, right guys? So this one gonna be limit, t approach negative infinity, this one is arctangent x, 0 and t, same thing. This one is a limit t approach negative infinity, arctangent 0 minus arctangent t. So this first part is 0 minus arctangent negative infinity. This value gonna be, guys, here. Guys, remember this one? This one is negative pi over 2. This is pi over 2 because tangent negative pi over 2 gonna be negative infinity. So that's why. So first one is also pi over 2. So pi over 2 plus pi over 2, this improper integral value gonna be pi over 2 plus pi over 2, that's gonna be pi. We study improper integral with unbounded interval. This time is another improper integral, unbounded discontinuity. Another way you say this one is vertical line in the boundary, in the interval. That's another way to say. So here is very important thing is f is continuous. This continuous is on the boundary b value. B is function is discontinuous. Another way to say this one is gonna be, he say x equal b is might be vertical asymptote line. That case, we're gonna define this limit t gonna be approach to be negative because here is the interval, guys, a and b. You're gonna take a t value here, approach to this direction. So that's going to left side. T gonna be approach to be negative, that's left. A and t, we're gonna take integral a and t fx dx. That's the first case. Second case, guys, here is dt discontinuous and a value, guys, a value. Another way, x equal a is vertical asymptote line. So this case, a and b, t gonna be taking here approach to the a from the right. T approach the a from the right, t and b fx dx. So each limit exists, this improper integral exists. I'm gonna give a couple of examples about this definition. Let's just start this improper integral. Look at this boundary. Here is 0, here is 1. Function is y equal 1 3 cube x is, what is vertical asymptote is, here is vertical asymptote line, x equals 0. But this is interval is 0 and 1. Here is 0 and 1. So we're going to take a t value right here. So this definition is a limit. T is approach to the 0 from the right. T approach to 0 from the right. That's you're going to put the positive. You're going to put the positive. Then integral 1 to t to 1, 1 3 cube x dx. Let's find the antiderivative 1 of cube root x, guys, here. So integral 1 of cube root x dx. This one is integral x negative 1 over 3 dx. So what is antiderivative? This is 1 negative 1 over 3 plus 1. X negative 1 over 3 plus 1. I'm not going to put the c because we don't need the c. This one is 2 over 3. You're going to flip it, 3 over 2, x 2 over 3. That's you find the antiderivative of this. So right here, limit t approach 0 positive, 3 over 2, x 2 over 3, t and 1. So you plug in the 1, 3 over 2, 1, 2 over 3 is 1, minus 3 over 2, t 2 over 3. So x approaches to 0 from the right. This value going to 0. So this limit gonna be 3 over 2. So guys, very helpful here. When you see the boundary, you have to make sure vertical asymptote, this function vertical asymptote is gonna be x equals 0. X equals 0 is right there. So I'm gonna explain number line right there. This is interval. You're gonna take a t greater than 0, then approach t approach to the 0 from the right. That's how to define the improper integral. This example is improper integral, which is divergent. That's gonna be, we're gonna do this example. First is, let's check it out, guys. So here, function is y equal 1 over x cubed. Vertical asymptote is gonna be x equals 0. See, x equals 0 is vertical asymptote, here is a 0. So we have to use definition of improper integral. So first you write down improper integral is integral, no, not integral, guys, limit. Limit integral, so I just write down the interval is right there. Here is a 0, here is a 2. Previous example is the same. Here is 0 is vertical asymptote. You're gonna pick the t value here, approach the 0 from the right. So t approach the 0 positive, t to 2, 1x cubed dx. That's you're gonna define this improper integral now. So let's find the integral 1 over x cubed dx, antiderivative, integral x negative 3 dx. That's gonna be 1 over negative 3 plus 1, x negative 3 plus 1. That's gonna be 1 over negative 2, x negative 2. We write it negative 1 over 2, x 1 over x squared. So I'm gonna put here limit t approach 0 positive, negative 1 over 2 times 1 over x squared, t and 2. Okay, now plug in here. So negative 2 gonna be, I'm gonna take it out here, guys. Negative 1 over 2, limit t approach 0 positive, 1 over x squared, t and 2. Let's plug in the 2 first. Limit t approach 0 positive, plug in the 2, 1 over 2 square minus 1 over t square. So now t approach 0 past the denominator, this part going to 0, meaning it's a whole thing going to infinity. So this is 1 over 4, negative 1 over 2, limit t equal to 0 positive. First one is 1 over 4. This is negative infinity. So negative, negative, positive, this is infinity. So this improper integral is not converge, diverge. Okay, guys, everyone make sense? This improper integral is a little different from previous one. Look at this function is right here, guys. Y equal 1 over x cubed. Vertical asymptote gonna be x equals 0. So 0 is not boundary. 0 is between the negative 1 and 2. So here is a number line right here. Here is negative 2, here negative 1, here is 2. Here's number line. Low limit gonna be negative 1, upper limit is 2. What 0 is right here in center. This vertical asymptote in the middle. So that case, you're gonna split this one, guys. Look at this one. You're gonna split this one. How gonna split this one? Integral negative 1 and 0, 1 over x cubed dx, integral 0 and 2, 1 over x cubed dx. Previous slides, so we already show this one is gonna be divergent. Previous example say 0 and 2, this gonna be divergent. So whole thing gonna be, this whole thing gonna be divergent. So which meaning is this integral is divergent. So make sure, guys, here this example is vertical asymptote gonna be between the negative 1 and 0. You're gonna separate this one. Find each improper integral. One of them is divergent, then this whole thing is divergent. Both are converged, and this integration is converged.